Solve the equation for y, and then evaluate when x equals -6. Now, mathematically, we would get the same answer if we went ahead and just substituted -6 in for x. But that's not what the problem asks us. It says solve the equation for y. Now, this is very important, and you already know this, for changing this standard form of a line into the point or into the slope-intercept form. So let's do it the way the problem tells us to. Well, we need to get y by itself. So the first thing we need to do is work with this 2x. We need to move the 2x term over to the other side. A common mistake is to try to divide by 2x. But what is the sign of 2x? This is its own term, so it's a positive. So to get rid of 2x and move it to the other side, we need to subtract that. 2x minus 2x is no x's, so I'm just going to bring down the 3y. And then I have a choice here. Another common mistake is to take the 12 and then minus the 2. And just say that that's 10x. But those aren't like terms, are they? Because a like term have the same letters to the same powers. And 12 doesn't have an x in it. So I can put my 12 first, or I could put my -2x first. I would rather have my -2x first because that's more of the form that slope-intercept comes from. And I'm going to add my 12 to the end. Now, to get rid of this 3, to solve for the y, I'm going to divide every term in here by 3, giving me y equals -2/3 x plus 4. Okay, so that's step 1 of the problem. Now we need to insert -6 in for x. So again, I'm going to remember to put it in parentheses because that does make a difference. Now, what is -2/3 times -6? That would be positive 12/3. And then I could reduce 12/3 into 4. So I really have 4 plus 4, and that equals 8. So when x is -6, y equals 8. Now you can check that on your calculators if you wanted to, which you probably don't need to, but if you wanted to, you could graph this and then make sure that when x goes through -6, y at that point is 8.